Now we're going to switch gears now from permutations and combinations to fundamentals of probability, section 11.4. Let's look at some definitions. Theoretical probability. First one, experiment. Any occurrence where the outcome is uncertain, such as tossing a coin. Sample space is a set of all possible outcomes. So when we toss a coin, our sample space will either be head or tails. Event we call E. So anytime you see E when it deals with probability, we're talking about the event. It says any subset of a sample space. Okay, and notice that for sample space, the variable S is represented as sample space. Theoretical probability only applies to situations in which the sample space only contains equally likely outcomes, all of which are known. And let me say something about theoretical probability. It's also, just make a note of this, and I definitely will be talking about this in class. It's a number, theoretical probability is a number between 0 and 1 that indicates the chance or likeliness of an event happening. How do we compute theoretical probability? Computing theoretical probability. If an event E has, and we call this N of E, equally likely outcomes, and its sample space S has N of S, equally likely outcomes, meaning the outcomes are the same, the theoretical probability of the event E, denoted by P of E, is, this is the formula that we're going to use for computing theoretical probability. P of E is equal to the number of outcomes in event E all over the number of outcomes in sample space we call S. For example, okay, so remember before I mentioned about theoretical probability has a number between 0 and 1 that indicates the chance or likelihood of an event happening. Okay, 1 or 100% certainty, 50% or 1/2 is a 50-50 chance, and 0% that it's impossible that this event will happen. So an example, a die is rolled once. Find the probability of getting a number less than 5. So we know on a die, we have one dot, then another side 2, then 3, then 4, then 5, then 6. But it says find the probability of getting a number less than 5. So we have here the event of getting a number less than 5 can occur in 4 ways. Because think of numbers that are less than 5 on a die. 1, 2, 3, and 4. So this is how we will represent our solution, where the event, remember P of E, the E representing the event, here is less than 5. So our numerator is the number of ways a number less than 5 can occur, all over the total number of possible outcomes. So what's the total possible outcomes from a die? We have a die that has 6 sides. So number of ways a number less than 5 can occur, which is 4. The total number of possible outcomes, 6, and it reduces to 2/3. So remember, theoretical probability, a number between 0 and 1, and 2/3 is between 0 and 1, and it indicates the chance or likelihood of an event happening. Let's do another example. You are dealt one card from a standard 52 card deck. Find the probability of being dealt a king. So here's an example of a 52 card deck. And then how many kings will we have here? We have a king of hearts, a king of clubs, a king of diamonds, a king of spades. Okay, so that's 4. Because there are 52 cards, the total number of possible ways of being dealt a single card is 52. We use 52, the total number of possible outcomes, as the number in the denominator. Because there are 4 kings in the deck, the event of being dealt a king can occur 4 ways. Therefore, we have P of the event, which is king, equals to 4 over 52, which gives us 1 over 13. And here again, that's between 0 and 1. Now let's look at empirical probability. And what does this mean? Empirical probability applies to situations in which we observe the frequency of occurrence of an event. So the key word here is frequency of keywords, frequency of occurrence. So here's the formula for the for empirical probability of event E is. So here's the formula. P of E, E meaning event, equals to observed number of times E occurs all over total number of observed occurrences. So we have here, there are approximately 3 million Arab Americans in America. The circle graph shows, here's our circle graph, that the majority of Arab Americans are Christians. If an American is selected at random, find the empirical probability of selecting a Catholic. The probability of selecting a Catholic is the observed number of Arab Americans who are Catholic, which is 1.26 million, divided by the total number of Arab Americans, which is 3 million. So we see our solution. We see the event. We have 1.2 divided by 3, which is 0.42. So that will be what we observe, the frequency of occurrence of this event. So theoretical versus empirical. A coin that is equally likely to land heads or tails is called a fair coin. Empirical probability can be used to determine if a coin is fair. Coin toss experiment. Okay. And that particular website is not working, so let's go back to our and we'll talk about this in class. Next example, we have here law of large numbers. As an experiment is repeated more and more times, the empirical probability of the event gets closer to the theoretical probability of the event.